Hello guys, and welcome back to another episode of chemistry. And of course, in this episode, we're going to continue our study of organic chemistry. We're still talking about the amines. So in this class, I'm going to be talking about the preparation of amines. Okay, so how do we prepare amines? Do not forget that this tutorial is brought to you by the one and only O3 Schools JAMB CBT practice app. The app is all you need to succeed in your exam. The app has all the past questions you need for your exam for all the subjects in one application. Has lecture notes structured according to the JAMB syllabus. Has question search feature where you can search for question according to topic, and all the questions that JAMB has set on that particular topic will come out for you to answer. Likewise, there's a mock challenge on the app every Saturday till 1 week to the main JAMB exam. In that mock challenge, all the students that are writing JAMB for this year will compete with each other to win amazing prizes, to get used to JAMB past questions, JAMB likely exam questions, understand how JAMB set their question, familiarize yourself with how JAMB set their question, as well as see your result release every Saturday, thereby building your confidence and tracking your progress for the main exam. So do not sleep on the application. Go to Play Store, download it. It is also available for your laptop and desktops. Okay, the software version is available for download. To download that one, simply go to o3schools.com/JAMB app and you will download it automatically into your laptop or your computer. So please do not sleep on it. Activate it. Activation key is not up to the price of rice and chicken in a very good restaurant right now. So do not waste your time and be stingy to yourself. Okay, that activate it and enjoy all the utility that comes with it. Now let's talk about preparation of amines. So amines can be prepared. We are going to basically look at two ways you can use to prepare amines. Okay, so number one is a reduction of amides. When we reduce amides, we get amines. Okay, so this reduction can be done by a very strong reducing agent such as lithium aluminium hydride. Okay, Li, the one we call LiAlH4. This is lithium aluminium hydride. It can reduce an amide to an amine. So let us quickly see that. Number one, reduction of amides. Number one, reduction of amides. Okay, by LiAlH4, lithium aluminium hydride. Okay, lithium aluminium hydride. So if you have an amide like this, aryl CONH2, this amide. Okay, it can be reduced. Okay, by lithium aluminium hydride. Okay, number one, lithium aluminium hydride in the presence of water. Okay, to now give us an amine. Okay, so you may be asking, what is the water here for? The water is for workup. It's the use of this water in this reaction is just for the reaction work up. Okay, and it's to neutralize the most basic reagents at the end of the reaction. It is used to neutralize the most basic reagent at the end of the reaction. So we use lithium aluminium hydride, then also use water. So these are our amide. Our amide. Okay, then of course what we now have there is our amine. Okay, we're going to have our RCH2NH2. Okay, so it's as simple as ABC. So when an amide is reduced, what we get is an amine. So this one is our amine. Simple as ABC. So let us see an example. Let's say an amide like this, C double bonded to O NH2. Okay, let's say it is being reduced by our lithium aluminium hydride AlH4 and H2O. Okay, what it will give to us is simply we're going to have our C. Okay, then I'm going to have our NH2. Okay, so it's as simple as ABC. So if you can complete your structure like this. Okay, like this. Okay, so H. Okay, so our structure is complete, and then this is our product. Okay, this is our product. This is going to have your H, your H, and then here what your H. Okay, so it's as simple as ABC. What's the name of this amine that is produced? It has having what 4 carbon atoms, so that will simply be what a butylamine. A butylamine, that is what that is formed. Okay, like I told you, the purpose of this water here is for the reaction work up to neutralize the most basic reagent at the end of the reaction. All right, now we progress. Let us progress to another method we can use to prepare what amines. That is a nucleophilic substitution. Okay, that is nucleophilic substitution. Number 2 is nucleophilic substitution. Let's quickly look at that. Number 2, which is the second and final method we are going to consider in this class. That is number 2, and I'm going to have what nucleophilic substitution. Okay, so this is one of the methods we can also use to prepare amines. And in this nucleophilic substitution, basically we are reacting ammonia reacts with an haloalkane. Okay, we react ammonia with an haloalkane in this what nucleophilic substitution. So basically what you're having, you have what NH3, which is our ammonia, its lone pair of electrons reacting with what an haloalkane, like let's say a chloromethane, okay, which is what methyl what chloride, okay, or your chloromethane. And then what do we have? It forms what a salt. Okay, we're now going to have our what now? Our CH3. Okay, then we're now going to have our NH3. Okay, this is CH3, this is our NH3, CH3, NH3. Then what is left is what? Is Cl. This is what our salt. So this is what our ammonia. This is what? Our haloalkane. And then what is left here is what? Our what now? Our salt. Okay, our product here is what? Is the salt. So this is what happens, okay? When what ammonia reacts with an haloalkane, we get what? A salt. Now, but the main purpose here, the first thing we want to first of all prepare, okay, is a primary amine. The purpose of this nucleophilic substitution, we are first of all preparing what? A primary amine. Okay, so to prepare a primary amine, there are 2 conditions that we must take into cognizance. Okay, in nucleophilic substitution, the reason why this can work, okay, the reason why this substitution can work is because ammonia has what? The nitrogen that is present in the ammonia has what? Lone pair of what? Of electrons. You know what nucleophiles are, right? Nucleophiles are electron pair donors. Okay, so they donate what? Electrons. So because of that reason, the nitrogen present what? In this what? Ammonia can easily substitute what? The chlorine present in this what? In this haloalkane. Okay, that is why what? Of course, we can what? Easily do what? Nucleophilic substitution here. All right, so you substitute it, and then we now have what? A salt. So if you want to prepare a primary amine, 2 conditions are very important. Number 1, the solvent we must use. The solvent used must be ethanol. So we use what? Ethanol as what? As the solvent. Then number 2, we use excess ammonia. We use what? Excess what? Ammonia. So number 1, we use what? Ethanol. Then number 2, we use what? Excess ammonia. If we do not use excess ammonia, the reaction, the amine that will be produced will react again with the haloalkane here, and then it will now form what? A secondary amine. We can even further what? See react with what? With that secondary amine that is formed. Okay, that is this haloalkane can see further react to that secondary amine to give us a tertiary amine. All right, so please take note of that. That's why we must use ethanol as the solvent, and then number 2, we must use what? Excess ammonia. Now, this chlorine has been substituted. Okay, we now have what? Our salt. For us to get our primary amine, what we do is to react this salt with concentrated sodium hydroxide. Okay, when we react CH3, NH3, Cl, this salt with concentrated sodium hydroxide, it will now release back to us our primary what? Amine. Okay, so we take that salt now, which is our CH3, okay, NH3, all right, Cl minus, okay, then we react it plus now, plus NaOH, which is our sodium hydroxide. So what it does is that it releases back to us our parent what? Our primary amine. It releases back to us our primary amine. So I'm going to have our CH3 NH2. Then of course I'm not going to have our NaCl plus NaCl, then plus what now? Plus H2O. Plus H2O. All right. So this will now be what? The product of what? Of our reaction. Okay. I'm going to have what? A primary amine. I'm going to have a salt and then have what? Water. Okay. As what? As product. All right. So this is what our product, and then we are what? We are okay. This is what the name of this amine that is produced is called what? Methyl what? Amine. It's a methyl amine. Okay, so it's as simple as ABC. So if you want to make or prepare rather a secondary amine, what happens is that what from this first reaction we will not use excess ammonia. Okay, yeah, we will not use excess ammonia. All right. So if we want to produce our primary amine, we must use excess ammonia. But if we do not want to produce our primary amine, okay, we want to produce our secondary amine, what we do is we use what? Little what? Ammonia. We do not use what? Excess. Okay, we'll just use what? Enough ammonia. We do not use excess what? Ammonia. So now what do we do to make what our secondary amine now? What we do simply, we now take this primary amine that is formed, we now react with this haloalkane again, to react with it again, because here we did not use what? Excess ammonia. This primary amine that is formed will now react with this haloalkane, okay, to now give us what? A salt again. So let us see that. So for secondary amine, number 2, for secondary amine, all right, what will happen is that what? Now this primary amine that is from CH3 NH2, okay, will react with what? The haloalkane CH3Cl, okay, then nucleophilic substitution will occur again. Then we're going to have what now? What are we going to have? We're going to have our CH3 into brackets 2, okay, because I have CH3 here, CH3L. So CH3 into bracket 2, then I'm going to have our NH2, then I'm going to have our Cl, okay. So this will now be what? Our product. This will be the new salt that is formed, okay. But we do not want this salt. It's not a salt. Our purpose is not to produce a salt, okay. Our purpose is to produce a secondary amine. So what we do also is to further react it with sodium hydroxide, okay. So let's do that. So we're going to now have our salt, which is our CH3 2 NH2 Cl minus, then plus what? NaOH, okay. Once this is done, and I'm going to have our secondary amine CH3 2NH, okay, then plus what now? Plus NaCl, then plus what? Plus H2O, okay. So it's as simple as ABC. So we have produced our secondary amine. All right, now to now produce our tertiary amine, this secondary amine that is formed will now react again with this haloalkane again, all right, to now give us another salt, which will now in turn also react to sodium hydroxide to release our tertiary amine. So let's go. It's that easy. So I'm now going to have our CH3 for tertiary amine now, and I'll put it down for tertiary amine. Tertiary amine, then this secondary amine that is from CH3 to NH, okay, will now react now with the haloalkane CH3Cl minus, then this will now give us another salt, that is CH3. Now it will now be what now? This is 2 plus this one 3, okay, and I'm going to have a CH3 3. I'm going to have our NH, then plus what now? Okay, sorry, NH, then Cl minus, okay. So this is now the new salt that is formed. CH3 into 3, our NH, then Cl minus. Now, to release our tertiary amine, what do we now do? We react this also with sodium hydroxide. So that if we react that salt, CH3, 3, NHCl minus, if we react it with what? Rather, react it with sodium hydroxide, concentrated sodium hydroxide. What I'm going to have now is what? I'm going to have our tertiary amine, CH3, 3 what? N, okay, then plus what now? Plus NaCl, then plus what? Plus H2O as product. This is our tertiary what? Amine. So it's as simple as ABC. If you want to what? Prepare a primary amine, make sure you use excess ammonia and what? Make sure the solvent is what? Is ethanol. Also for secondary amine, you must use ethanol as solvent. For tertiary amine, you must use ethanol as what? As solvent. The reason why I'm using ethanol as solvent is because what? Because of what? This water. We do not want water to compete, okay, with what? With ammonia in this reaction, because water also has lone pair of electrons. Okay, we do not want competition. All right, so you have to what? Make sure that we use ethanol. Water has 2 bonding pairs and 2 lone pairs, so you cannot afford for water to be competing with ammonia, okay, well, with what? With nitrogen, okay, in this reaction. So that is why we need to what? Use ethanol, okay. So please ensure you take note of for these reactions. So to produce a primary amine, simply use excess ammonia, okay? Use excess ammonia. All right, but if you want to produce a secondary amine and tertiary amine, you do not use what? Excess ammonia. All right, so my name remains Master T. I'm the Grand Commander of the O3 Schools Army. I'm glad you joined us. Please ensure you download the application and ensure you keep studying and ensure you keep practicing your way to success. Study vigorously like your life depends on it, and you see fruitful results coming out of it. Thank you for watching. See you in the next episode. We'll talk about the reactions of amines.